Let's take a look at question 5 from the 2018 November paper. This is from the Department of Education. Sketch below are the graphs of f of x equals ax squared plus q and g of x equals a half raised to the power of x minus 4. A and B are the x-intercepts of f. The graphs intersect at A and point E lies on f. C is the turning point of f and D is the y-intercept of G. Now let's take a look at question 5.1.1. Write down the coordinates of point D. Now to find the y-intercept of the graph g of x equals a half raised to the power of x minus 4, we substitute x equals 0 into the equation. So let's do that. G of 0 equals a half raised to the power of 0 minus 4. Now anything raised to the power of 0 is equal to 1. 1 minus 4 is equal to negative 3. So the coordinates of D are 0, negative 3. Now let's take a closer look at the marks allocation. You will get 1 mark for correctly identifying the x value, x equals 0. And then you will get 1 mark for correctly calculating the y value. Y equals negative 3. Let's continue with question 5.1.2. Here we have to determine the range of g. Now the graph of g of x equals a half raised to the power of x minus 4 has a horizontal asymptote at y equals negative 4, meaning y approaches but never reaches negative 4. Therefore, we can say that the range of g is y is greater than negative 4. So here you will get 1 mark for identifying the correct range. Let's take a look at question 5.2.1. Here we have to calculate the coordinates of point A. Now to find the x-intercept of the graph g of x, we set g of x equal to 0. So let's do that. Now, what we want to do is we want to isolate for x. So what we'll do is we'll try and get x alone on the one side. So first we take the negative 4 over to the other side and it becomes a positive 4. Then we rewrite 4 in terms of its prime factors, so it's 2 raised to the power of 2, and we rewrite a half raised to the power of x as well. It becomes 2 raised to the power of negative x. Now we have the same base numbers, so we can set the exponents equal to each other. Negative 2 equals 2. X has to be positive, so we divide by negative x on both sides. X equals negative 2. So that means the coordinates of A is equal to negative 2, 0. Let's take a look at the marks allocation. You will get 1 mark for correctly solving for x by equating the function to 0, and you will get 1 mark for correctly stating the coordinates of A as negative 2, 0. Let's take a look at question 5.2.2 from the 2018 November paper. Calculate the values of A and Q. Now, for the quadratic function f of x equals ax squared plus q, we substitute the points E and A. So let's start with substituting point E with coordinates 1, 3. So now we have 3 equals A times 1 squared plus q. And now we simplify, so it becomes 3 equals A plus q. And this is, of course, equation 1, so you can number it. Now let's move on to substituting point A with coordinates negative 2 and 0. So now we have 0 equals A times negative 2 raised to the power of 2 plus q. Now negative 2 squared equals 4, so it becomes 0 equals 4a plus q, and you can number this equation 2. What we'll do now is we will solve the system of equations. So what we'll do is we will rearrange equation 2. So it will be q equals negative 4a. Now that we have a value for q, we can substitute this value of q into equation 1. So we have 3 equals a plus negative 4a. Now a plus negative 4a equals negative 3a. So after we combine the like terms, we have 3 equals negative 3a. Now we want to isolate for a because we want to solve it. So what we'll do is we'll divide both sides by negative 3. Then we get a equals negative 1. So we have the value for a. It is equal to negative 1. And now we can substitute this value into q equals negative 4a. So then we have q equals negative 4 times negative 1, and that equals 4. So q is equal to 4. Now let's take a look at the mark allocation. You will get 1 mark for the correct substitution of point E. You will get 1 mark for the correct substitution of point A. You will get 1 mark for calculating A equals negative 1, and you will get 1 mark for calculating Q equals 4. Let's take a look at question 5.3 from the 2018 November Department of Education paper. So we'll start with question 5.3.1. We have to determine the length of CD of this line segment. Now, let's take a look at where this is. Here we have point C with coordinates 0 and 4, and here we have point D with the coordinates 0 and negative 3. So what we have to do now is we have to determine the vertical distance between these 2 points. So let's start with that. So we can say CD is equal to the y-coordinate of C minus the y-coordinate of D. So now we have 4 minus 3, remember, a negative and a negative equals a positive. So 4 plus 3 equals 7. So CD is 7 units long. Let's take a look at the mark allocation. You will get 1 mark for the correct substitution of the coordinates, and then you will get 1 mark for calculating the correct distance of 7. Moving on to 5.3.2. Here we have to determine the equation of a straight line through A and D. So the points A and D lie on the line. So what we'll do first is we will start by calculating the gradient. Remember, we have the coordinates for A and we have the coordinates for D. So let's substitute these coordinates, these x and y values, into the gradient formula. So we have negative 3 minus 0 over 0 minus 2. So that equals minus 3 over 2. So this is the gradient. What we'll do next is we will use the equation of a straight line y equals mx plus c, with m being negative 3 over 2 and point A. So let's substitute the x and the y value of point A into the straight line equation. So then we have 0 equals negative 3 over 2 times negative 2 plus c. Now, negative 3 over 2 times negative 2 equals 3. So then we have 0 equals 3 plus c, which means c has a value of negative 3. Now that we have the value for m and c, we can rewrite the equation. It is y equals negative 3 over 2x minus 3. Now let's take a look at the mark allocation. You will get 1 mark for calculating the gradients of m correctly. You will get 1 mark for the correct substitution into the line equation, And then you will get 1 mark for writing the correct equation, y equals negative 3 over 2x minus 3. Let's have a look at question 5.4 from the 2018 November paper. For which values of x is f of x greater than 0? So the quadratic function f of x equals ax squared plus q is greater than 0 when the graph is above the x-axis. So the x-intercepts of f of x are x equals negative 2 and x equals 2. So f of x is greater than 0 between these two intercepts. So you will get 1 mark for identifying the critical values negative 2 and 2, and you will get 1 mark for writing the correct range. Now let's take a look at 5.4.2. For which values of x is f of x decreasing? If you take a look at the graph, you will see that the quadratic function f of x is decreasing to the right of its turning point at x equals 0. So for x is greater than 0, the function is decreasing. So here you will get 1 mark for correctly identifying that f of x is decreasing when x is greater than 0.
And that's a wrap on today's fascinating journey through the world of knowledge. Don't forget to hit that subscribe button and join our ever-growing community of curious minds. We can't wait to embark on new educational adventures together.